Hi, my name is Callie. Today I'll be talking about the big project in quarter 3 for high school math 2. So my big project is about geometry and trigonometry. So in this big project I will be proving that a rectangle is a rectangle and that a quadrilateral is a parallelogram, like a given parallelogram is a quadrilateral, and using geometry and the properties of the shapes. I'll also make a shape bigger or smaller, which is dilation, and uh, but the thing is it doesn't change because both the smaller one and the dilated one are the same and they're congruent because they still have the same angles. It's just one is larger than the other one. And I'll also build a bridge using trigonometry, like hypothetically speaking, at a local river. So basically, in this big project, what we do is we just use the trigonometry and geometry in real life. This is the introduction. So in this quarter, we learned about geometry. We learned about like lines and angles and vertex segments and everything. And we learned about like proving that a rectangle is a rectangle, parallelogram is a parallelogram, and like finding the distance of a river. Those that's also gonna be in one of the tasks that we do. Um, Also, we learned about like the different formulas that we use to find the volume of 3D shapes. Uh, so I also learned how to prove that two lines are parallel, and some of the ways that two lines are parallel is that if they have the same slope and they're both perpendicular to a third line. I also learned how to find the center of a triangle. Basically, we find the midpoint of each of the lines, and connect them to the vertex on the opposite side, and the three lines will cross at one point, and the point as the center of the triangle. I also learned how to calculate the surface area and the volume of different shapes, like the cylinder, the sphere, um, and like the cube. So the formula for calculating the cylinder is V equals pi r squared h. So r is the radius and h is the height, and pi is pi. Um, so the surface area for calculating the cylinder would be pi rh plus 2 pi r squared. And I also learned how to calculate, like how to find the width of a river or a spring by using either cos, tan, or sin. Uh, they all have like a function, which is cos is adjacent side of the triangle over hypotenuse. Um, Tan is opposite over adjacent, and sin is opposite over hypotenuse. So like in a triangle, in a right angle triangle, the straight line, the first one, it's called the opposite, and the line under it is called the adjacent, and the slanted line, we usually call it like ABC, and the slanted line is C, that is the hypotenuse. So the methods that I used in this big project, in the first task, it's just like defining the terms that we use often in this big project, which is like midpoint, centroid, parallel, line, like basic words that we use. And the task 2, the first question was to construct a quadrilateral and prove that it is a parallelogram. So here's what to remember. The first thing is like a parallelogram has diagonals that bisect opposite sides and are parallel and congruent. So I use the quadrilateral ABCD, which has A is like -4 and 4B is -6 and -4, C is 8 and 4, and D is 6 and -4. So the first thing I have to prove is that they're parallel, and then to do this I have to use the slope formula, and I have to prove that AD and BC are parallel. So if they have the same value, it means that they are parallel. And AD has 0 over 12, and BC has 0 over 12 as well. So this means that these two lines are parallel. And the next one is that AB and CD are parallel. These are also parallel, and we can know because like the answer is -8 over 12, a negative 8 over negative 2, and this one's also negative 8 over negative 2. Task 3 in this task 3 is like we have to prove that a parallelogram is a rectangle. The things to remember are like the opposite side of a rectangle is parallel and they have the same slope. Opposite sides are congruent, and when two slopes are multiplied, they have negative reciprocals. First I drew the rectangle. It says triangle here, but it's supposed to be rectangle ABCD, and I took the coordinates to prove that the opposite sides are parallel. So I used the slope formula again, and since they have the same value, they're parallel to each other. So now I have to multiply them together to see that if they bring -1, and they do. So for each, basically the method is I just wrote about like what I did in each task. So task 1 is defining. So isosceles triangle, medians of a triangle, centroid, what I kind of talked about earlier. And like these definitions are given to us because we use them like a lot during the quarter, and it's like the basic thing we need to know in order to answer like any of the questions that are given to us. So in task 2, I already explained up there, it's about proving that a quadrilateral is a parallelogram. Task 3 is proving that a rectangle is a parallelogram is a rectangle. So I used the slope formula to do that, and then after I got the two slopes, I had to find that they're negative reciprocals, and I multiplied them together, and the answer is -1. So negative reciprocals are like two slopes, and when you multiply them together, the answer has to be -1. Since it is, then ABCD is a rectangle. So task 4, it's to draw a triangle and dilate it by the scale factor of 2.75. So the way I can know is that like I multiply each of the coordinates by 2.75, and it becomes the coordinate that's given on the dilated one, and it also has the same angles, like more than two of the angles are the same, so then I can know that these two triangles are congruent. In task 5, we have to rotate the triangle by 45 degrees counterclockwise. So we kind of know this, we kind of like know that it's congruent with the same thing as task 4. Like for example, these two are congruent because they have two of the angles of both of them are similar. So actually 3 of them are similar, so it means that these two triangles are congruent. Task 6 is finding the width of the river using the trigonometry. So what I did is I used the cos formula. So if I wanted to build a bridge, so I walked 15 meters, it's supposed to be 50 meters to find the width of the river, I'll use cos. Cos is adjacent over hypotenuse. So cos times 64, which is the angle of me looking over there, it's 64. So we multiply by cos, it'll be 0.43, and then we divide it by the meter that I walked from my starting point to the end point, and then we can see that the hypotenuse is 34.88. So if I wanted to build a bridge, it'll be 34.88 meters. Task 7 is that there's this guy named Jack, and he has a cottage in Khao Yai. That's like a place right outside of Bangkok. So the view is very like it's really pretty, but there's a tree blocking his house, and what I have to do is he wants to cut it down. I have to see that like if the distance between his house and if the tree will fall on his house. So what I did is like I put his cottage, which is this, and then this is the tree. So the distance between him and the tree, his cottage and the tree, is 7 meters. So the angle is 37.62, and so I use the tan, which is opposite over adjacent, to find the hypotenuse, and the height to find the adjacent side, sorry, uh, to so that I can find the height of the tree. So tan times 27.62 times 7 will be 5.39 meters. So this means that this is the height of the tree, and the distance between him and the distance between the cottage and the tree is 7 meters. So no matter which side it falls on, right or left, it would still it would not fall on his house. So Jack can merely cut the tree and enjoy his view. So task 8 is I'm trying to find the lowest amount of aluminum that this company can use, but without changing how much drink they can put in the can. So what I did is, for the radius, which is well, the diameter would be 6, and so half of it, on the side, the radius would be 3, right? So the the formula for calculating the cylinder is V equals pi r squared h. So then I put the radius 3 in r's place, and then I put the height, which I do not know yet, but I assumed it. So then I moved 200 to the other side, and I multiplied pi by my assumption, which is 3, and then I got the answer, and I divided 200 by 28.27, and the height of the drink will be 7.07. So the reason why I chose this answer is because the can will not be too fat or too tall. It will just be the right amount, and then the company does not have to use a lot of aluminum, and they can still sell a lot of drinks and keep the price at the same. They don't have to change it. So this is the discussion and the conclusion. So basically, uh, in this quarter, I think we learned to use trigonometry in this big project. I think we learned to use geometry and trigonometry in real life, like for the building a bridge thing. We had to actually go to the river and then find the distance from our starting point to the end point, and then find the angle and just calculate everything so realistically. So this shows that we can actually use math in real life, and it might not be seen we might not think of it every day, but math is actually all around us. And yeah, that's basically what I'm talking about in my discussion and conclusion. In the next part of the video, I'll be explaining the different standards that we took in quarter 3.